Very much.
Okay, thank you very much. Hello, everybody. My name is Shaoying Liu, and I'm from Hosei University in Tokyo. This is my first time to Russia, and I have been long for this visit. Finally, I realized my dream. And after coming to this conference, I surprisingly, but also happily understand that most of you are from industry. But I'm working at the university, but I have been working for industry because my purpose of developing some new technologies is try to support the practice in industry. So that's why I'm talking today about the latest results of our research over last several years on our Japanese government funded project. So the title of my talk is Agile Formal Engineering Method for High Productivity and Reliability, because the productivity is a major concern of companies and the reliability is the major concern of the users. Both of them are very important, but the challenge is how to enhance the productivity and the reliability. So my proposal is is a kind of agile formal engineering method. What do I mean by that? So today I'm going to quickly go through these issues because the time is very short for my presentation, so I can only give you a general idea of what I'm doing. So first of all, I'm going to explain whether we can fall in love with the agile approach or not. But anyway, and then I talk about the SOFL formal engineering method, give you a general idea what do I mean by a formal engineering method, and then I believe the combination of them can possibly come up with a positive solution to the problem. And then I will focus on a brief introduction to the detailed techniques involved in the Agile-SOFL. So this doesn't work, it seems. Okay, the first question is, can we fall in love with Agile approaches? It seems these days everybody is talking about the Agile approach. According to my own research and application experience, I believe that yes and no is the answer. It depends on what kind of project you are doing. If your project is small and short, let's say about 5,000 lines of code for the scale and less than 5 months, then I think probably you can go agile. That will be okay, no problem. But once you try to talk about larger scale product, there are many people working on the team. You need a very good communication, cooperation. The period of the project is long, and then I think it will be very difficult for just using agile. Okay, the reason is in software development process, 3 key activities are very important. The first thing is understanding. Understanding is everywhere throughout the entire process. The developers need to understand the customers' requirements, and the programmers need to understand the designers' ideas, and so on. And suppose we have done a good understanding, and next job, which is the most challenging, is the creation. Creation of the architecture, creation appropriate data structures, creation the efficient algorithms. And suppose we've done some work over there, the final job is confirmation, because all of the creation is done by humans. At the moment, we haven't got any robots which can replace humans. Therefore, humans always make mistakes. We need to confirm whether our product satisfies the original requirements or not. But let's look at how Agile deals with these 3 activities. The Agile, there's a manifesto with 4 points. I think this kind of the individual's interactions of process and the tools is just a talk. And I think maybe the second, the third point, other key points. So working software over comprehensive documentation. I see some reason for that. It's because almost 100% of my students, when they develop software, they don't write documentation. They go straight to the coding, which is not necessarily good because eventually I saw them suffering. But in the beginning, they feel good. So this is some motivation there. Customer collaboration over contract negotiation, I think this is very important, but in practice can be challenging because customers say, oh, I'm sorry, I'm too busy to be available for your project. So anyway, ideally, this is very good. Even in our, in some formal approach, we do need the customer's collaboration, but sometimes customer can feel very difficult. Okay, so the last point is responding to change over following a plan. This is just a token. Let's look at the advantage and disadvantage of Agile approach. I think the advantage is working software because they can quickly show the running of the software to the customer, then get the feedback and quickly remove. So this sounds very good. But when the system grows, the scale becomes large, it's like when you make a snowman. When it's small, you feel enjoyable, but when it's big, and then, you feel very difficult to manage. The reason for that is that when you try to, you need to keep frequent changes of your code to improve it, because once you get feedback from the customer, but in order to do this, you need to first understand your code. And when the scale becomes large and the structure becomes complex, reading the code is not easy. And also when humans make a change, you will possibly introduce new bugs in the system. So let's look at the other options instead of Agile approach. There's a formal engineering method called the SOFL formal engineering method, which I developed. Emphasize the formal specification-based techniques. So first, you use mathematically, once we talk about mathematics, it sounds very serious. But actually, it's a discrete mathematics, basically logic. Based language to precisely define the potential functionality of the system or the user's requirements, and get a good understanding of what you should do in the beginning of the project. So this is very important. Many projects goes wrong because there you haven't done a very good job. Therefore, you quickly go into the coding phase. That's the problem. But also, if you have a formal specification, then you can possibly do some testing and verification of your system. But here, the verification is more practical techniques like inspection and testing, not a formal verification. And possibly, those techniques can be fully automated to many situations. But the challenge is still there. We need to write a formal specification. Although to many of us, writing formal specification is not that difficult if people are well trained. But actually, in practice, it's still even a psychological barrier. And I have a lot of collaborations with industry in Japan to China. But my experience is that once you use formal technique, usually the project, the company just use once. And then they never come back. So this is an unfortunate situation. But for me, I need to think not only their problem, whether there is any problem with the formal approach. But I realized that according to my experience with Japan signal company, they like not a fully formal specification, but it's rather a kind of combination. So later on, I will take. Okay, the SOFL idea is try to combine the formal specification with the graphical notation, so that you use the graphical notation to play the role of the guideline. And when you build your specification, you draw some diagram, and then you try to use the textual rather formal description to define the semantics of the components occurring in the diagram. So in this way, I found that if people just use a graphical notation, it's not efficient. It's not because when you evolve the documentation, it takes a lot of time. So the balance is very important. I think everybody understands the life. The balance is very important, not on the extreme to either situation. So the question is whether the disadvantages of agile approaches can be overcome by taking advantage of the SOFL formal engineering method. If yes, how to do that? I think for industry, for engineers, we need to provide a solution, not only talk about a problem. You see, in software engineering, we have so many problems to be talked about, but there are very few positive, effective solutions to be provided. If you look at the books of software engineering, it's so thick and very few positive solutions. So here, I'm trying to provide solutions for you. So I propose the Agile-SOFL. I try to apply, combine the Agile with the formal engineering method to propose the Agile Formal Engineering Method. The specific techniques involved in the Agile-SOFL include a three-step approach to building comprehensible hybrid specification. By hybrid specification, I mean the mixture of a semi-formal specification and a formal specification. How to use them properly depends on what kind of application and you are developing. And there are some principles to be provided in our steps. And another technique we use is animation-based techniques for specification validation. After you take a long time write your specification, you need to make sure the specification does accurately and rather completely reflect the customer's requirements before you undertake the implementation step. So here, I understand the reason the Agile approach try to propose the working software. But the effect of the working software is not necessarily only achieved by coding. You can achieve by other means. For example, the animation. Without the code, I have only the specification. I can do the animation to demonstrate the potential functionality of the system to show the customer without coding. Then the customer gets give us the feedback, and then I learn that and I improve the specification. After I get a good specification, I will have a firm foundation for the implementation without causing any chaotic situation. So that is a very good point for animation-based. And also the point is animation can be rather automatically or semi-automatically done. So it's quite efficient. And the third technique we use is a testing-based formal verification. Well, I guess many people are not really involved in formal method, except one famous professor sitting here, he knows. But as far as I understand, most of you are not involved in formal verification. Formal verification is a technique in the formal method, reasoning about the properties or correctness of software based on logic. But anyway, that's why it's very hard to be applied by engineers in industry. But the testing is good, but the test cannot prove your program has no bugs. Therefore, the combination of testing with the formal verification will provide us with a much better situation. And the greatest advantage of this technique is you can press button, and we just chat and drink, and the computer will list up all of the bugs for you. But of course, at the moment, we can't automatically fix. The last technique is incremental implementation together with the application of TBFV. So after you have a specification which define precisely and completely what you should do in your final system, then you take an incremental approach. Choose one part, implement that. If it's ready for release as a product, you release. Then choose another one. And so there's no chaotic situation to occur. So the principle of the Agile-SOFL is that in order to attack the software defects and errors, you don't try only one method. You try different methods from different directions, different phases. But of course, all of the techniques should be connected in a systematic way so that the effect of them will be great. So the Agile-SOFL three-step specification plus the GUI-based specification animation, and then specification-based incremental implementation, and the testing based formal verification. These three come together in a systematic way. Let me give you a brief introduction to the three-step specification. Actually, our idea is to write a specification for the potential system, but in the beginning, we know very little about the system. Therefore, we need appropriate, efficient communication with the customer. Therefore, we first write the informal specification, because the informal specification can be easier for the customer to access. And then we, based on the informal specification, design your GUI, graphical user interface. Through that, you can quickly demonstrate to the user, and especially you choose the user, interested functions first, and then implement the GUI to demonstrate the potential idea. And then based on the GUI and the informal specification, you will write the specification, because you now have in a better position than previously, just based on informal specification. You know exactly what kind of input and output should be provided for the related operations, because you have done this job. Okay, this is just the process of how to provide some help, transformation from the informal specification to build the GUI, and then come back to eventually realize a hybrid specification. So this is in the informal specification. What should we write? Write three things. First, the functions to be implemented. Second, the data resources that will be necessary for implementing those functions. And finally, the constraints, safety, security, business restrictions, policies, and so on. Whatever constraints you want, you can write. But all of them are in brief description and informal. And then this is just a simple example. And then you, based on the informal specification, choose those user interested properties, and especially the functions which need the direct interaction between the user and the system. You try to realize the GUI. You design the GUI. Can the GUI be automatically designed? No. All of the design job is a creative job, so you must. But of course, you can borrow some original idea. This is just some example. You can use some tool which can help you what kind of GUI structure can be possible. And then after you get the GUI, you need to write the hybrid specification. So the major task for the hybrid specification is that if you use the SOFL language, which I just mentioned, you need to form processes for each function given in the informal specification, and define their data flow dependency using the condition data flow diagram, which is a formalized data flow diagram. Okay. Write specification for each process. Semi-formal specification basically emphasize the well-definedness of the input-output variables, but the function of the operation can be defined using informal pre-post conditions. But the formal specification requires both pre-post condition must be formally defined. Okay, so this is just a semi-formal specification example, a withdrawal for a bank system. This is a formal specification. Pre-post condition are fully written in the logical formula. Okay, so suppose we have done a very good job in the specification, and then you can do the incremental implementation. The idea is that we have already got a set of modules, and you choose one module, generate the program automatically or manually. In many cases, it must be manually. And then you test your program. If you realize that this version can be released, you release. Otherwise, you go on. Choose another one. So another technique is testing-based formal verification. So we needed to check whether the program you have developed satisfies the specification or not. So we use the TBFV. The essential idea of the TBFV is that this is theoretical foundation. For every initial state which satisfies the precondition, you run the program with this initial state, you get the final state. That final state must satisfy the post condition. If for every initial state, the results satisfy the post condition, then you haven't found a bug. But doesn't mean so there's no bug. But if this is true, this is false, then definitely you find a bug. And the point is this technique can be fully automated, including the generation of test data and the test results analysis. So in the future, but not yet, and you press a button, we just chat and enjoy ourselves. The computer will automatically come up with a list of the bugs. But fixing the bugs is very hard to be fully automated, but you can try on some certain case. Right, okay. So this is just the steps, and this is just the technical details, how to do that. Basically, we're based on a kind of functional scenario, which is a conjunction of the three conditions. Based on that, you can generate test data. You can also derive the test oracle for automatically evaluate your results. So this is the test oracle. Okay, as far as the tool supports are concerned, we have produced many prototypes at the university. One of them, which can be used, is the Agile-SOFL specification construction tool. Another is a testing tool. It's just the diagram show you. You draw the diagram, which is data flow, and here the architecture of the whole specification will be automatically generated based on the structure of the diagram, but the contents must be filled out by humans. And this is a tool for testing the Java program and SOFL specification, and the tool will provide you with some variables and proposed conditions and automatically generate test data and so on. Okay, the conclusion and the future work. I believe the Agile-SOFL is much more effective than existing Agile approaches for high productivity and reliability, but I haven't really applied this to a real industrial project yet because of many constraints. And the second is I believe the Agile-SOFL is this is just a summary of Agile-SOFL, characterized by the three-step specification approach, animation, and the specification-based incremental, and the testing-based formal verification. And the third point is Agile-SOFL supports the 4 points of the in the Agile manifesto. But of course, using a different strategy, and the degree of supporting might be different from the original Agile-SOFL. Okay, future development. We developers our tools and ask students who are going to industry to apply the tools to use our method, and so they get used to that, and in the industry they can use that. And in the future, I think the tools need to be more, smarter, to be more intelligent. So we need to study more about that, the intelligent software engineering environment. Well, I have been working in the academia since I graduated from university, but I'm always concerned about the industry. In Japan, there's one person from the industry, he said, "Oh, I haven't met any professor who is like you are concerned about our problems." Well, I said, the reason is my background is software engineering. I'm not the mathematician, I'm a software engineer, computer science. So, but these days, we have a bigger gap between the academics and the industry. The reason is that the demand for the different communities are different. In academics, if you try to do research, you must, I think at least you should think like this, must make simple things as complicated as possible. Otherwise, your paper will be very difficult to be accepted, according to my experience. But when you make engineering, you must make complicated things as simple as possible. Otherwise, the people in industry wouldn't accept that. So this is a big gap, but it's very difficult to bridge that. So my work tries to bridge them, try to provide a good solution for industry. That's all for me. Thank you very much.
Thank you very much. So please, any questions from the audience? Okay, just a minute. Try to catch that. Okay,
no problem.
Great.
Terehov Mikhail, St. Petersburg State University. Okay, you have mentioned testing-based formal verification as an important part of your method.
Yes.
But we ran through it rather quickly, and well, I couldn't get. Okay, testing and formal verification are two ways to examine your, I don't know, project. But they are fundamentally different. Like you may test it by running it through some test cases, or you may do formal verification. But I couldn't get how could you fuse it?
Yeah, that's the point. That's why I'm interested in this technique. You see, as you said, testing requires the running of the program. And the verification does not necessarily to do that. So our idea is you first automatically identify all of the interesting properties of your program, convert that into a theorem. Theorem means you have a hypothesis, you have a conclusion, and then you try to automatically test whether the theorem is valid or not.
But you have already proven it if you have done formal verification.
Oh, no, you haven't proved it. You just list up the hypothesis and list up the conclusion. You haven't demonstrated that the hypothesis will lead to the conclusion. You haven't. So if you carry out the formal verification, you have to use axioms and rules and so on to reason about. But here, we do automatic testing. You press a button, it will generate the test data to satisfy hypothesis and to see whether the same test data will satisfy the conclusion or not.
Okay, I see. You can write precondition and postcondition for your program.
Yeah.
But then where is formal verification here? You just automatically test it.
No. Yeah, that's why this technique is a combination of the two. Therefore, you can't fulfill the original purpose of the formal verification. You have to make a compromise. So that's why. But the compromise will bring the rigor of the testing, make the testing more rigorous, systematic, and automatic. That's the point.
I see.
Okay, please, any questions? More questions? Okay, yeah, please.
This is interesting.
Okay, great.
Yep. I didn't understand everything, but I'm a bit surprised by your focus on the user interface, on the GUI, because to me this is the easiest part. I mean, you do the difficult thing, and then you do the difficult stuff, and then you, in your sleep, you build the GUI. So maybe I misunderstood, but I have the impression that you concentrate very early on the GUI, and to me it's more important to concentrate on the core stuff. I mean, on the model part of an application.
Thank you. This is a very good question. Actually, I have experience of writing many kinds of specifications, but when you write the formal specification or even semi-formal specification, you need to determine what kind of input variables, output variables should be used for each operation, and what kind of type should be used to declare each of them. But there, if you do not understand the customer's requirements on some functions like ATM withdraw or deposit, then you yourself may propose some type, propose the number of the parameters for your operation, which is not necessarily required by the customer. But as a developer, you understand, I should use this in order to easily write your proposed condition. But actually, later on, when you show to the customer, oh, no, this is not what. So here, by designing the GUI, first bridge, communicate with the customer. Then the customer understand for withdraw, for example, in ATM system, I only need to provide password and the amount of money. Others, I don't care. Then, when you write your specification, you understand for the withdrawal, I only provide this input. That's the only idea we have. Because otherwise, you have to evolve your specification. When the specification gets complicated, you take time. So in order to avoid the rework, we propose the GUI. And also this reflects the agile approach. So quickly show the potential behavior of your system to the customer so that communication can be done very well in the beginning. And then you get a better idea. For example, the refinement in our formal approach, when you apply a law to refine the abstract program into the concrete program, you do need to resolve the non-determinate. But ideally, you should consult with the customer, but nobody does that. Therefore, you decide eventually, maybe the result is not satisfactory. Okay, thank you.
More questions? Okay, yeah.
It's a little far from you.
Please. Oh, okay, good.
Hi.
Could you return animation-based specification validation?
Sorry. Animation? Yes, please keep talking.
Well, I not understand how looks animation.
Loops.
How you store this?
Right, okay. Here. Is this the page you want to raise a question about?
No,
No? Well, what page?
maybe 4, 5.
Previous?
Previous,
This one?
previous.
This one?
Yes.
Okay.
How you store animation?
Animation.
How looks this? Animation-based techniques.
Right. Okay, the animation in our idea is that, so when you write a specification for let's say, focus on single process operation, okay? It provides input variables and output variables, and also use well-defined types to declare those variables, and then use precondition and post-condition to define the functionality of the operation. Now the question is, when you try to demonstrate this idea to the customer, you need to show what kind of input can lead to what kind of output in order to let the customer understand what you try to define. Because this is, everybody, when they learn new things, you need to understand examples. So that's, we generate the test data for the input variables, you can call animation data. And then we also, based on the post condition, to generate the output. Then we prepare the input output. Then we use a kind of a tool to show how the input is lead to the output. Then let our customer observe this process. And possibly you can animate the data itself, because data, sometimes the structure can be complex, like a set of a sequence of a set and so on. So you have to tell the customer what does this kind of data represent and so on. So that's the idea. The animation is basically to demonstrate the relationship between the input and the output in a kind of a dynamic way, a dynamic visualized way.
Okay, thanks.
Okay, thank you very much. So, okay, I have a quick question. So,
Yes.
I just believe that many of the questions are raised here because obviously you have more information than you could fit into this short talk,
Yeah.
because you had to skip through that. And maybe even if we can't understand the details, of course, they can be proven on practice.
Yeah.
So that's why I just wanted to reinforce your vision, whether it's feasible, like you say, that what you believe that your graduates will finish their university, they go to work in Japanese companies.
Yes.
Presumably to some large corporation as a trainee.
Yes.
And then there they say, okay, let's throw away all your old methods and try something that I just learned from my professor. So
okay.
you think it's feasible?
Well, it's a very good question.
Well.
According to my experience with several companies in Japan and China, I think it's not easy. Not easy. Yeah. Usually, the company try to incorporate your technology into their already well-established process. Unless they find the original process is not working very well, they want to adopt. But this is usually they try to incorporate. So I teach my students, don't try to copy all of the technique, copy some part of the technique.
Like soft power.
Yes, soft power. Yes, that's right. And
so like infiltrate.
Yeah.
And reform from inside. Oh
yeah.
wow.
And you work, and they bear for a while until they become the head of the project, the head of the project. Then they have the right to decide.
So that's a very, very dangerous proposal. Beware of these person's graduate students.
But the good news is that all of the students come out from my lab are welcomed by the industry. They always invite quickly.
So
come in.
they will blow up your companies. Okay.
Because at least they are well trained.
Wow.
So here, implicitly, will help them improve the quality.
Okay. Thank you very much again.
Okay,
thank you, the audience, for the questions. And important thing, I think the lunch is served.